Bienvenidos, Ushamadid, and welcome UMGC learners for the CMIT-455 Section 6380 Spring 2021 semester. This is the CCNP ENCOR version 8 curriculum from the Cisco Networking Academy, and in this supplemental tutorial for Chapter 6, we're going to continue our journey with VRF-Lite and examining different use cases. Now, we left off with our diagram where we have configured VRF-Lite between routers 1 and 2 on dedicated individual physical links. We have configured VRF-Lite between routers 2 and 8 using a single physical link and then carving that physical single link into sub-interfaces. And in the predecessor video, the previous video to this video, for part 3, we took a single physical point-to-point serial interface, and using back-to-back frame relay, we were able to carve that physical serial interface into individual point-to-point sub-interfaces. We have Ospf, which is VRF aware, running between routers 9, 8, 2, and 1, and we have full reachability across our network over to the red subnet, which is being simulated by a loopback address, the blue network, and the green network, again, all being simulated with loopback addresses. So let's go ahead and confirm that we have connectivity from router 9 over to those 3 networks. So let's log on to router 9 here. We'll go from user exec as indicated by the greater than sign into privilege exec, and I'll simply say ping VRF red to the 10.1.1.1. We've got full connectivity there. What about ping VRF blue to the 10.2.2.1? And then finally ping VRF green, and I guess we'll put the IP address in here, to the 10.3.3.1, and that was unexpected. We'll hit, it wanted IP. I forgot to hit enter there. So we'll say ping VRF green, and let's pull all that back. Ping VRF green to the 10.3.3.1, and we have connectivity there. So connectivity is working end to end. So what are we going to be learning how to do in this video? And what are we going to be talking about? Well, we're going to be using VRF-Lite to create, using GRE tunnels, and I'm going to draw a little cloud in here, right? This is kind of a cloud. And we're going to say that this is an MPLS service provider layer 3 VPN cloud. Layer 3 VPN cloud. Now, we've been able to carry our customers' traffic or our tenants or our departments, whatever the case may be here for red, blue, and green. But we've been able to segregate and separate and isolate each of those networks' traffic from each other right up into this point here. And so now we're going to hit a service provider network. And maybe router 9 is located in Alaska and router 3 is located in, who knows, let's say Florida. And so we're going to use a layer 3 MPLS VPN service from the provider. Now, the reason I'm saying this, again, this is just sort of the scenario that's being laid out here to lay the foundation for what we're going to be doing. In reality, physically, what I have is a single router here in between these 2 routers. And all it's doing is sort of simulating a service provider with no MPLS, no layer 3 VPN. I've configured the VRFs on this router, but it's going to facilitate me doing this. Now, this again would probably be done in an MPLS L3 VPN scenario where you've got your traffic locally, right, or geographically all the way up here to router 9. It's been able to float all the way to router 9, but now you need a provider to sort of give you that transit between Alaska and Florida. Obviously, if you're a company, you probably don't have that set up out of the gate. And so we're going to be using what this simulated MPLS L3 VPN here. We're not going to see the details, but that's okay, because that's kind of the scenario we're going to be working with where you may see something like this. So let's go ahead and clear the screen. Let's get control of the mouse. And again, the black lines I have here are just to kind of simulate a tunnel. And then it's the red, the blue, and the green VRF in here. And we've got this cloud in here, so to speak. And I'm using the Gig 01 interface and the Fast Ethernet 01 interface. And actually, this is Gigabit Ethernet 02. Right? So here are the public IPs for these physical interfaces. So it's going to be 209.165.129.9, because that would be a publicly routable IP, and 209.165.123.3, because it would also be a publicly routable IP. Now, do these have to be publicly routable IPs? They don't, but that's just kind of the scenario that we're going to go with here. So let's jump onto the command line, and let's start on router 9. And I've actually taken care of some of the housekeeping that we might be doing here, which would be creating those sub interfaces here. And again, I'm doing that 802.1q tagging. Now, we do this with our in-house service provider. We do sub interfaces and we do 802.1q tagging in order to allow our individual routers to support more than a single VRF. And so as long as the provider is giving us end-to-end separation and segregation of the traffic, which they would be, because these were going to be different VRFs from end to end through the provider network, we're going to be just fine. So I've already configured these interfaces along with the addresses. If I say show run int fast ethernet 01.10, you can see that everything is currently in place. Can I ping the providers? Let's say ping VRF red to the 209.165.129.12. And it's router 12, if you're wondering. That's the router in between routers 9 and 3. All right, so we've got that set up. Now, what is it that we would need to do here? Well, we're talking about doing VRF-Lite with GRE tunnels. And so what we're going to do right now is we're going to go ahead and we're going to set some of those tunnels up. So let's get into global config, and actually we'll set the single tunnel up and get it working, and then simply wash, rinse, repeat, right? All right, so we're going to go into interface tunnel 10. Sorry about that. Interface tunnel 10. Now, we need to go ahead and say VRF forwarding red, because this command, remember, what does this command do? It takes my interface from the global routing table and moves it into the VRF routing table, or going from the global routing context to the VRF routing context. So we say VRF forwarding red. Then I'm safe to put my IP address on here. Now, the tunnel IPs can be 1918, RFC 1918 addresses. They can be private addresses, because these will only be seen, on the GRE tunnel, right? So I'm going to say 10.3.9.9 for router 9. Again, it's between router 3 and router 9. So the second octet's the lower router number, third octet higher router number, and then the fourth octet the router number. So we'll make it a /24. And so we've got our IP address on here now. So now what we need are the tunnel source and the tunnel destination. Well, the tunnel source address is going to be the 209.165. It's going to be that sub interface on Fast Ethernet 01 that faces router 12. So my source address is going to be 209.165.129.9. And again, if I said do show run int Fast Ethernet 01.10, you would see that that's the IP address. And so that outside sort of quote-unquote publicly routable IP, that's going to be the IP that I use. Now, where am I going? So my tunnel destination is going to be what would be the quote-unquote the publicly routable IP for the 209.165.123.3. That's router 3's publicly routable interface on the opposite side of what we're saying is this MPLS Layer 3 VPN cloud. And so we've got that in there. Now the conversation is going to turn to not so much optimization, but configuration best practices. Generic Routing Encapsulation, GRE, as you've read, it requires 24 bytes of overhead for the MTU. And so the max MTU is 1500, so we would drop this to 1476. Now, if I was using AES encryption or triple DES, right, you would have different amounts of overhead that you would have to account for. Now, sometimes you'll see, and it doesn't have to be exact. I could have come in here and said IP MTU 1400. I'm just trying to keep it under 1500 with the additional encapsulation, which is the GRE encapsulation. So remember, the GRE tunnel, if this is my IP packet, right, at layer 3, this is the original source and destination IP, which is going to be the tunnel source, right, and then the tunnel destination, those publicly routable addresses for the source and destination. The tunnel IPs, the IPs on the actual tunnel interfaces, interface tunnel 10, those would be encapsulating that original IP address information. And so here is the GRE header. Now there's a little flags field in here as well, but in the GRE header, it takes up 24 bytes. And so we need to account for that encapsulation overhead. Now, if we were doing IPsec and we were using GRE with AES with, let's say, SHA-1, we would be looking at a roughly sort of 75 to 80, or closer 75 to 77 bytes of overhead. And so then we would shrink this number down even further. So again, it's to avoid fragmentation. We don't have to have it exact. So I don't need to figure out, well, is it 75 or is it 77, right? So 1400 is a common value that you'll see in some cases. What I use is I'll say 1360, right? And that ensures that even if I'm using GRE and AES and SHA-1 or whatever the case may be, that I have plenty of room for all of the headers that are going to be involved in encapsulating that IP packet. So let's stick with IP MTU 1360. All right, so what do we have so far? Do show run interface tunnel 10. All right, so the VRF forwarding command has placed the tunnel into the red routing context. If I say do show, what am I trying to say here? IP route VRF red, and we might not see it yet because it might not be up, and then we've got all this information here. So yeah, we don't see it yet because the interface isn't actually up, but when it comes up, this is the routing context it would be placed in, and that is what we ultimately want. Now, we're running Generic Routing Encapsulation GRE. The default keep alive time is 10 seconds. And then if you miss, just like with the hello packets and the hello interval and dead interval with Ospf, GRE has a similar type feature that we can manipulate. And this is one that we probably want to set up unless we were running IKE v2. And IKE v2, which would be our encryption of the traffic in the tunnel, has the capability, and it actually is running keep alives at the IKE v2 level. So I wouldn't have to say keep alive, and if I do a question mark, you'll see this is the period, right? So this is the hello interval, and this is what would be that number times the hello interval to give us the dead interval. So if I say that it's 3, if I back up and do a question mark, you'll see how they do this. It's the retries. So I'm going to say every 3 seconds, I want a keep alive packets sent across my GRE tunnel to make sure the tunnel is alive. If I miss 3 of those packets, in other words, my dead interval is 9 seconds, then we bring the tunnel down. And so we'll do that because we're not using IKE v2, right? If we were using IKE v1, we would want to set the keep alive. That's one of the major differences between IKE v1 and IKE v2 when it comes to that IPsec protocol suite is that IKE v1 does not have keep alives, IKE v2 does. All right, so we've got all this sorted out. Let's take one last look. Do show run interface tunnel 10, and we've got one more very important command that we need to add here. But this is what we have right now. We've got our tunnel source and destination. The keep alive and the MTU is set. The IP address on the tunnel is set. And it is in, or will be when it comes up, in the VRF-Red routing context. Now, I saved the best command for last because this is the one that tends to cause some confusion. And the final command is going to be tunnel VRF-Red. Now, you can probably see how that command is going to cause confusion. Because as you're looking at that, you might be asking, well, wait a second, we already said VRF forwarding red. Why now do I have to say tunnel VRF red? And the reason is that while the VRF forwarding command places the interface into the red routing context, the command tunnel VRF red is saying use that VRF for your source and destination addresses of the tunnel. And so, again, we place the interface into the red routing context with VRF forwarding red. Now I need to tell this tunnel interface in which VRF context do you go look for the tunnel source and destination IPs, because what I could do here is I could say tunnel VRF purple. If purple was a VRF and I wanted this traffic to use that VRF's routing table to resolve my source and destination tunnel addresses, but we don't, right? We don't. You could do something like that, but here we've already carved up subinterfaces using 802.1q tags, just like we did on the second video, using a single link between the routers. And so I'm going to say tunnel VRF red, telling the tunnel that for the source and destination IPs, use the VRF red routing context. It's not good enough when we're doing this VRF-Lite configuration with GRE tunnels to simply put the tunnel interface into the red routing context. I need to tell the tunnel what VRF context or what routing context to look at in order to resolve the source and destination address information. And then this would lead us to a conversation down the road when we talk about front door VRF, which is outside the scope of what we're doing here. But keep that in mind, front door VRF. All right, so we've got our configuration all set up here. If I do show run int tunnel 10, you can see that everything is laid out. VRF forwarding, the IP, the MTU is set, our keep alives are up and running, tunnel source and destination, and then the tunnel VRF red to resolve those tunnel source and destination IPs. Now let's say do show IP route VRF red. And you'll notice that we don't see the tunnel interface in the VRF routing context because do show IP interface brief. When we look at tunnel 10, what do we see? It is up, down, meaning layer 1 connectivity, we've got everything configured here, but layer 2, the protocol on the other end has not been configured. And so this is going to say up, down. And when you have issues with serial links, a lot of times you'll see something like this when you're doing PPP for your encapsulation. or even HDLC. Typically PPP is going to be used, where you'll see up, down. And this simply means that I'm good here on this router, but the protocol for GRE is not coming up. And that's because we don't have anything configured on the other side. So let's save our configuration here. And then let's transition now over to router 3. And so here we are on router 3, and let's go from user exec as indicated by that greater than sign to privilege exec with the enable command, and let's say show IP interface brief. Now, I have set the sub interfaces up, but if I say show VRF, you'll see that we don't have any VRF information set up. And so we're going to have to take care of that as well. The loopback addresses, the same thing. I've got loopback 1, 2, and 3. The addresses are there, but we don't have VRF information. Again, I staged some of this to save us a little bit of time in terms of configuring things. And so now let's go ahead and go into global config, and we'll start out with the interfaces between router 3 and the service provider, right? That cloud that sits between router 9 and router 3. So I'm going to go into interface gigabit Ethernet 02.10. We're going to say encap.1q10. Now, what's going to happen if I say VRF forwarding for VRF read? It's going to say the VRF's not configured. So remember, we want to say VRF definition read, address family IPv4, and then VRF definition blue, and address family IPv4. And then we say VRF definition green and address family IPv4. Whoops, IPv4. All right, so the VRF is complete. We get back into gigabit Ethernet 02.10. Now we can say encap.1q10, and which we did previously, and more importantly, we can say VRF forwarding read. And now I can put the IP address, and the IP address is going to be the same on all 3 sub interfaces. So I'm going to say IP address 209.165.123.3. That is router 3's IP address for this sub interface. Interface gigabit Ethernet 02.20, encap.1q20, VRF forwarding blue, and then the IP address, which we'll just pull back with the up arrow. Then we're going to go into interface gigabit Ethernet 02.30, and we're going to say VRF forwarding green. Whoops, green. We're going to go ahead, we can drop our IP on there and then say encap.1q30. So let's take a look at our sub interfaces. Do show run interface gigabit Ethernet 02.10, 2.20, and 2.30. And they should all look the same with the exception of the .1q encapsulation along with the VRF definition. But the IP address for all 3 of those interfaces is the same. So let's test our connectivity over to the sub interfaces that the provider has connected. So do ping VRF read to the 209.165.123.12. Again, router 12 kind of playing that role for us. And then do ping VRF blue the 209.165.123.12. And what I could also do is simply hit the up arrow and scooch back a little bit here and change blue to green, right? Because the IP address is not changing. So we've got connectivity now between router 3 and the provider, right? Very, very important. Connectivity between router 3 and the provider is established. Connectivity between router 9 and the provider is established. Now, do you think I can ping VRF read over to router 9 yet? 129.9. And again, my ping command is correct, VRF read, and we're trying to ping the VRF read subinterface on router 9, but we can't do that. One of the first things to do to troubleshoot this is to say, do show IP route VRF read. Let's see what we've got in our routing table here. Well, that's it. I can see the problem right now is I have no route to get to the 209.165.129. And we're going to be addressing that. And again, in a VRF static routing is VRF aware. We're going to be addressing this on both router 9, because right now router 9 has no idea to get to the 209.165.123.0 network. And both router 9 and router 3 need to know how to reach each other's sub-interfaces that are connected to the provider cloud in order for the tunnel source and destination information to bring that tunnel up. And that has not happened yet, but we'll get to that shortly. All right, so we've got the sub-interfaces configured. Do show IP interface brief for gig 02.10, 20, and 30. Let's take care of our loopback interfaces. So interface loopback 1, VRF forwarding is going to be red, and we're going to say IP address, and it's just going to simply be the quad 3s and quad 255s for a /32 host route. We're going to go into interface loopback 2, and we're going to say VRF forwarding for blue, and I can simply hit the up arrows to save some time. Interface loopback 3, VRF forwarding for the green VRF, and then we've got the IP address assigned. So we've got all of the locally defined IPs that we need and the IPs we need to connect us into that service provider cloud, and we've proven that that connectivity works. So now, and again, we're just going to do tunnel 10 out of the gate, and as soon as we get that working, we'll simply replicate what we did with tunnels 20 and 30 for VRF blue and green respectively. So let's go into interface tunnel 10. We're going to say VRF forwarding red. Again, we're putting this tunnel interface, we're moving it from the global routing context into the red VRF routing context. Once I've got the VRF forwarding red on here, let's put the IP address on here, 10.3.9.3. Remember, this is the tunnel IP address that we're going to see for tunnel 10, not the physical sub-interfaces. Those just give us our source and destination reachability. The tunnel is what allows us to basically simulate a point-to-point connection through the service provider cloud for the red VRF. So what we're really doing is we're extending, again, the red VRF through a service provider infrastructure using a GRE tunnel. So I'll say IP address 10.3.9.3. Let's take care of the IP MTU 1360, making sure we have no concerns about, so we'll do, let's do keep alive. Sorry, I had the space in there. Keep alive 3.3. And then we want to do our tunnel source is going to be 209.165. It's going to be that address that we just put on all those Gigabit Ethernet 02 sub-interfaces, 123.3. And then tunnel destination is going to be router 9, 165.129.9. Now, most importantly, we need to tell this tunnel which VRF to use to sort out that source and destination information. Inside which virtual routing and forwarding context do I look for that information? And so I'll say tunnel VRF red. Now, if we had our static routing configured, let's say do show run interface tunnel 10. If we had the static routing information configured so that router 9 knew how to get to router 3 and router 3 knew how to get to router 9, we would be set. But we've got to add that in. We don't have that information right now. If I say do show IP interface brief, you'll see that we don't, because again, over on this side for tunnel 10, the tunnel is up, down, meaning I'm not seeing the other side of the tunnel. Maybe the tunnel destination IP is wrong. Maybe the tunnel source IP is wrong. So something's not correct, and it's that they don't have reachability. Again, do show IP route VRF red. You'll see there is no route in the red VRF routing context telling it how to get to that 209.165.129. So let's go ahead and let's add in these static routes. So the first one's going to be, IP route VRF red, and I'm basically saying to get to the 209.165.129.0, and remember this is a subnet mask here on a static route, not a wildcard mask. what's going to be my next hop IP. So 209.165, and again, this would be the service provider. Now, I could also do something like put a default route here, but I want to be very specific with this and say 123.12. And so that is the next hop IP, which, and that's why I ran this command right before I set the static route up. And you can see that 209.165.123.12, I'm telling the tunnel, use VRF-Red to sort out the tunnel source and destination information. And right now I'm sticking into VRF-Red a static route that says, here's how you get to that 129 network, and use that IP right here as my next hop. And that is also in VRF-Red. So let's type in, let's say write mem, save our config, make sure we don't lose anything. And so what do we see now? Show IP interface brief. It's still going to show us that it is up down because router 3 knows how to leverage VRF-Red and has the static route, but router 9 does not. In fact, we got logged off of router 9 due to inactivity. So we go from user exec back into privilege exec, back into global config. We're going to say IP VRF-Red to get to the 209.165.123.0, and then subnet mask for the static routes. My next hop is 209.165.129.12. Again, router 12, who's pretending to be sort of our MPLS L3 VPN service provider cloud. Now, when I hit enter, we should see something happen here in terms of our tunnel interface. And there it is. You got to love it when a plan, the big build up here, me telling you we've got to do this and this is what we have to do and this is what this means with tunnel VRF-Red and VRF forwarding red. This is exactly what we just saw happen. Tunnel 10 change state to up. So now when I say show IP interface brief, we'll see that our tunnel interface is now up. And if that's the case, I should be able to say ping VRF-Red and ping the tunnel IP 3.9.3 on the other side of the tunnel. And look at that. Works like a champ. So let's now go ahead and knock out the other two tunnels that we would need to configure that are going to look very much like tunnel number 1. Now, keep in mind, I also need, if I say do show run and then include route, I'm also going to need that routing information right there, the same routing information for VRF blue, and then I'm just going to copy and paste here, and IP route for VRF green. Right, so I need that same information for both of those. If I say do show run int tunnel 10, let's see if this is going to be a cut and paste I can make. And it will be, I'll have to do that piece right there. I can cut and paste to kind of shorten the configuration work. So interface tunnel 20, I'm going to go ahead and say VRF forwarding blue. We're going to say tunnel VRF blue. And then I should be able to cut and paste. And we're good to go with tunnel 20. Now I'm going to say interface tunnel 30. We're going to say VRF forwarding green. Sorry, misspelled green there. VRF forwarding green. And that's okay. Tunnel 20 went down because tunnel 20, while it came up at layer 1 here, it's configured. Again, we haven't configured the opposite side yet. We have to do the static routes for the VRFs on the other side, as well as the tunnel interfaces on the other side. So here we say VRF forwarding green and then tunnel VRF green. And then I should be able to cut and paste that information in. So let's say do show run int tunnel 10. And we know tunnel 10 looks good. Tunnel 20 and tunnel 30. And again, they're all using that same set of IP addresses and the same sort of configuration. And then we have it that tunnel 30 goes down as we would expect it to do. So let's save our config here, again, just in case there's any power issues. And now let's come back over here. Let's get into global config on router 3. Let's say do show run include route so that we can grab this piece of that configuration, stanza and simply say IP route VRF blue and then copy and paste, and IP route VRF green, and we paste that in there. So there we have all of the static routes. If I was to say do show IP route blue, sorry, do show IP route VRF blue, there's my static route. What about a do show IP route VRF green? And there it is. So when I say tunnel VRF green or tunnel VRF blue, the static routing information to reach the destination network is in there. And that is going to allow us to have that tunnel come up. All right. So we're good here, and I just lost my train of thought. We've configured do show IP interface brief. I think we need to do each of the tunnel interfaces, and that's what's next. So do show run int tunnel 10. And what we're going to do here is the same thing we just did on the other side, right? And you can see how the sub interfaces and the VRF-Lite config and using the same IPs makes this a little bit easier to tackle. Interface tunnel 20, VRF forwarding blue, tunnel VRF blue, and then cut and paste the rest of our information in there. Interface, and you can see tunnel 20 initially said down, but now it says it's up. Because remember, the static routes are in there, the other side is configured, and now it changed to down. So we'll take a look at that in just a second here. Oh, sorry, I want to say interface tunnel 30, and we're going to say VRF forwarding green, whoops, VRF forwarding green, and then tunnel VRF green, and then we can paste in, and that is not what I wanted to paste in. Let me go back and grab the config information for the tunnel here, the MTU, and in fact, let's make sure. All right, and so there we go. So let's go ahead and say end, and we'll say write mem, save our config. And now let's take a look at show run int tunnel 10, make sure I didn't have any mistakes in here and no typos. And it looks like tunnel 20 and 30, I may have missed something. Show run include route. And let's make sure that that is correct, and that is. And then let's say show run int tunnel 20, because I've got a typo somewhere around here. Ah, of course. I forgot to put the address for the I went here, I grabbed that, I apologize. My address was going to be the same, so let's grab that. And I think I just figured out why the tunnel interfaces went down on me. So interface tunnel 20, let's drop an IP in here. Interface tunnel 30, and let's drop the IP address in here. And let's say end, save our config just in case. And what we should see here in short order, show run interface tunnel 10, show run interface tunnel 20, and show run interface tunnel 30 is that these interfaces should come up. How can I test? Let's say ping VRF blue over to 10.3.9.9. So do I have reachability across the tunnel here yet? Not yet. It's probably in an up-down state. And so let's do this. Let's say show IP interface brief. And it looks like it is in an up-down state. So let's get back into global config. And sometimes we have to give it a kick. So interface tunnel 20. I'm going to shut the interface down. And then interface tunnel 30. And we'll shut that interface down. We're just going to shut them down and then bring them back up. So then I'm going to say no shut on interface tunnel 30. And then interface tunnel 20, I'll say no shut. And then let's save our config. And let's say show IP interface brief. And let's make sure these are going to stay up. Again, tunnel 10 is up. We're not having any issues there. And we are still up down here. And let's check a few things here. So show run int tunnel 10, show run int tunnel 20. So it's red and red and blue and blue. and the information's correct, and then interface 30, and then let's say show run include route. The static routes are all correct. Let's take a look here at show run int gigabit Ethernet 02.10, and did we not configure? It should be configured 2.20. Okay, so that is configured. And the encap statement is correct, right? VRF 2.30. And that is correct. And so we have an issue between router 3 and router 9. And it's probably some stupid typo on my part because tunnel 1 is up and not having any issues. Let's take a quick look here at our ISP to make sure I didn't leave something off over here. Show IP interface brief and show run int show run. And so we'll say show run int gigabit 01.10. Let's make sure that that's red. 1.20. Make sure that's blue. 1.30, and that is green, and then we're going to check 2. Whoops, sorry about that. Now the screen is kind of lagging behind, so give me a second here. I just wanted to see, yeah, 210, 220, 230. So 2.10, and that's correct. 2.20 should be the blue VRF. And that is correct. And 2.30 should be the green VRF. All right, so we've got an issue here. Let me take another look. Show run interface tunnel 10. Show run interface tunnel 20. And what is it that I'm not seeing here? And again, I don't want to waste too much time with this. Show run include route. And so the blue and the green routes are correct. So show IP route VRF blue. Let's see what we see in VRF blue. I've got my static over to the 129. And let's come here to router 9 and say show run VRF of show IP route VRF blue. And let's make sure we've got the static route over to the 209.165.129. And we do. So then let's check show run VRF green, or not show run VRF green, sorry. Show IP route VRF green. And do we have that static route that we need? We do, and we have it over here as well in both the blue and the green. And this should be taking me over to the 209.165.129. And so those interfaces do not want to come up. Show IP interface brief. And again, unless I'm missing some typo here, which is definitely possible. If you've watched any of my videos, I definitely get some typos from here from time to time. Okay, so I'm going to circle back on tunnel 20 and 30. Let's finish the configuration here. So for tunnel 10, let's extend out tunnel 10 with Ospf. So what about a show run section router Ospf? And sorry, router 3, we haven't configured anything. I was like, wait a second, where'd my Ospf config go? Show run section router Ospf. So here on router 9, we've got that configured, and I want to get into global config, and we'll say router Ospf1 VRF red. Now remember, we've got new interfaces involved here. So we're going to say no passive interface, fast Ethernet 01.10, because that is the sub-interface for VRF red on this router. Now once I've done that, we're going to go ahead and say network 209, I'm sorry, we're using the GRE tunnel interfaces here. I almost forgot. So we're going to say network 10.3.9.9, right? We're going to give the exact IP address, and we're going to put that in area 0. So we're now running Ospf over this GRE tunnel between router 9 in router 3, or we will be shortly here, as we need to get onto router 3 and finish up some configuration work, namely router OSPF1, VRF, and did I say VRF red over here for router OSPF? Okay, I did. I'm always panicking thinking maybe I didn't put in the VRF name, so VRF red. So we'll say router ID, and we'll just go 0003 and follow the convention we've been using. We'll say passive interface default, no passive interface, gigabit Ethernet 02.10. Again, for that red VRF. Now, as soon as I drop in the network statement for the loopback address, 3333, with a quad zeros and area 0, now let's put in the network statement for the tunnel IP address, the GRE tunnel IP, 10.3.9.3, and we'll do a quad zeros there, and area 0. We should see here in short order an OSPF adjacency come up between router 3 and router 9. And we've placed that into the correct VRF, and we're running it over the GRE tunnel. And let's make sure that I did the no passive show IP interface brief, and it should be 02.20. Oh, my apologies. That's why I was thinking of the 209.165. We're going to say router OSPF. I'm sorry, router OSPF. Let's say, yeah, router OSPF1, VRF red, and then we're going to say no. So we've got passive interface default. We'll say no passive interface, or actually we'll passive the gig 02. So we'll say passive interface gigabit Ethernet 02.10. I was thinking that we're directly connected. We're not. We're using that GRE tunnel. No passive interface, tunnel 10. We need the tunnel interface on there. My apologies. Definitely wrapped around the axle here as I'm scrambling in my head to figure out tunnel 20 and 30, what might be going on there. And so here we're going to say passive interface fast Ethernet 01.10. Again, that's that physical provider-facing interface. We want it to be running, no passive interface, on the tunnel interface, the GRE tunnel. And there we go. And let's save our config here. We're going to save our config on router 3. And now we have an OSPF adjacency. If I say show IP route VRF red, we have that OSPF adjacency. And now look at all the routing information I'm getting. I'm getting router 1. I'm getting router 2, router 3, router 8, router 9. So look at all of that information that we're getting here. Now let's test. And here's what we're testing. If we go back to the diagram, I'm on router 3, and we're going to be coming across the red VRF, and I'm going to see, can I get to router 9? Can I reach router 8's loopback? What about router 2? What about router 1? And then can I reach the red VRF network over here? So let's clear the screen, and let's come back. And from router 3, let me say, ping VRF red, can I reach router 9? 9.9.9.9. And it works. What about router 8? 8.8.8.8. And so we've now just extended and continuing to provide that separation of our tenants, of our customers, of our departments, whatever we're using VRF-Lite to segregate, it's doing it for us. And now let's go to router 2, 2.2.2.2. Works like a champ. Can we get over to router 1, 1.1.1.1? We get there. Can I get to the network behind router 1, the LAN segment, 10.1.1.1? And everything is working beautifully with the exception of the 2 tunnel interfaces. So here's what I'm going to do. I'm going to pause. I'm going to dig here for a second and see if I can't figure out where I went wrong on those 2 tunnel, on tunnel 20 and 30, and see if I can't bring those back online. So let's take a quick pause here, and then I'm going to circle back and let you know what the issue was. All right, so to say that this is a little bit embarrassing, I swear we had put the IPs on interface tunnel 20 and 30. So that's the problem here, but I swear we put those on both sides, because when we saw them, show run int tunnel 20, and then I'm looking at the tunnel interfaces, not realizing that the IP address isn't even on there. That's our problem, right? So again, it happens, fortuitous failure. You got to go back, reset, take a look. Again, saved off the video that I recorded and started to take a look. And the first thing I looked at, I'm like, okay, well, let me take a look at these tunnel interfaces again, because I've got reachability for tunnel 10. So I know that I'm configured properly through the provider, router 12. And lo and behold, on router 9, the first command I run is show run int tunnel 20, and it says no IP address. How is that possible that we left off the IP address? So let's get into global config, interface, tunnel 20. And let's say IP address 10.3.9.9, and it should be a /24. And let's check, do show run int tunnel 20. Is it not taking? Okay, so that seems to be, oh no, there it is. Okay, it took it, right? Okay, good, good, good. I was afraid that it didn't take it as I looked at it. I'm like, wait a second, where did it go? So, perfect. Tunnel 20 is up. This was my problem. Interface, tunnel 30. And let's just hit the up arrow a few times because it's going to have the same IP. And so now tunnel 30 is going to come up here any second now. So I can save my config on router number 9 here. And let's say show run, or how about a show IP interface brief, in order to see that all 3 tunnel interfaces are up. Again, it gets a little confusing. We didn't put the tunnel IPs on there for whatever reason. I thought I had put those on there, and I thought we'd actually even looked at the interface config, and if I looked right by it, I apologize. So they're on there right now. So the only thing left for us to do, and let's knock out router 9 right now. Let's get into global config, and we're going to say router OSPF to VRF blue, and here we're going to get it right. No passive interface, no passive interface, tunnel 20, because that's in our blue VRF. Let's add a network statement in for the GRE tunnel IP 10.3.9.9, do a quad zeros, area 0, and then let's go ahead and say router OSPF 3 VRF green, and we're going to say no passive interface, tunnel 30, and then we're going to put the tunnel interface IP in there. And we're going to say network 10.3.9.9 with our quad zeros for area 0. And that should take care of the router 9 side. Let's save that off. And now let's come over to router 3 and do the OSPF config over here. And as you can see, if I was to say ping VRF blue and use the 10.3.9.9, we've got reachability over the tunnel interface, and change the VRF to green. And this is what's allowing us, or will here shortly, allow us to bring up the OSPF process between these tunnel interfaces. So router OSPF 2 VRF blue, and we're going to say no passive interface, tunnel 20. Let's get our router ID in here, because again, remember, we had no configuration over here on router 3. And let's say passive interface default. And now that I thought about it, let me do a quick check here. Let's just rerun that no passive interface tunnel 20 just to make sure. Let's add in our loopback address. So the quad 3s and the quad 0s is our wildcard mask for area 0. And then let's add in the 10.3.9.3 interface IP for the tunnel, that GRE tunnel interface. Now, as soon as I hit enter, we should see any second now, and there it is. From loading to full, the OSPF adjacency is now up for VRF customer blue or tenant blue or mission blue, whatever the case may be. Let's say router OSPF 3 VRF green, and let's wrap this up by saying router ID 0.0.3.33 and passive interface default, no passive interface, tunnel 30. And then let's add in our quad 3s for the loopback address. The quad 3s for the loopback address in area 0. And then let's add in our 10.3.9.3 with a quad 0, the GRE tunnel interface into area 0. We're going to see that that adjacency pops up, and there it is, very quick. We'll do a write mem to save our configuration. And let's go ahead and say show IP OSPF neighbors. And you can see we have 3 adjacencies, again, all to the same physical neighbor, but 3 adjacencies, 1 for each of the VRFs. And now let's do a little bit of testing. We're going to go all the way to the other end for blue and green to keep it simple. Ping VRF blue. Can I reach from router 3, the 10.2.2.1? Again, that LAN subnet being simulated by a loopback address behind router 1, and then let's ping VRF green for the 3.3.1. And we've got reachability. And so we've got everything sorted out. The problem that we had has now been sorted out. And so that is going to do it for this supplemental video tutorial, part 4 from Chapter 6, where we sort of simulated what if I was connected to a service provider running MPLS L3 VPN and I had a single connection to that provider, but I had carved up sub-interfaces because I wanted to ensure the separation and segregation of their traffic across the provider network. And so now we've done that, and we are all the way over here to router X. And so it's on router X between router 3 and what will be router X tomorrow, where we will configure a little surprise, but we'll still be using VRF-Lite. It's just going to have a different name when we go to use it. All right, that does it for this video tutorial. Again, hopefully you've got a better understanding of GRE, GRE tunnels, how they would be configured, and another use case for VRF-Lite. Thanks so much for watching, and I hope to see you in the next video.